Title: Dynamic Dialogue Generation Using Large Language Models in Role-Playing Games. Abstract: Role-playing games, RPGs, provide players with a rich, interactive world to explore. Dialogue serves as the primary means of communication between developers and players, manifesting in various forms such as guides, NPC interactions, and storytelling. This study introduces a dialogue filler framework that utilizes large language models, LLMs, enhanced by knowledge graphs to generate dynamic and contextually appropriate character interactions. The framework is tested within the environments of Final Fantasy VII Remake and Pokémon, providing qualitative and quantitative evidence that demonstrates GPT-4's capability to act with defined personalities and generate dialogue. Introduction. Role-playing games have been identified as a significant challenge for the next stage of artificial intelligence research. These games present a complex, open-ended creative arena where players interact through dialogue to shape the narrative and game outcomes. Unlike traditional games such as chess and Go, which are zero-sum and deterministic, RPGs require nuanced, context-aware dialogue. Players create characters that interact within a fictional setting, making decisions and taking actions that influence the game's progression. Challenge. One of the critical challenges presented by role-playing games is the necessity for nuanced, context-aware dialogue. Players create characters that interact within a fictional setting, making decisions and taking actions that influence the game's progression. Another challenge in RPG dialogue is the occurrence of unnatural silences from main characters or NPCs. In real-world interactions, conversations flow continuously, with participants actively contributing to the dialogue. However, in RPGs, there can be instances where characters remain silent, breaking the immersion and disrupting the natural flow of the narrative. Solution. To address these challenges, the study leverages advanced AI capable of maintaining continuous, contextually appropriate dialogue that aligns with each character's established traits, ensuring a more engaging and authentic player experience. The contributions include integrating knowledge graphs and LLMs for dialogue generation and evaluating the capability of current LLMs technology. By leveraging advanced algorithms and AI, the study aims to produce dialogues that match the quality of those written by humans, thereby optimizing resources and enhancing the overall player experience. Methodology. The study focuses on addressing specific challenges encountered in two different games: Final Fantasy VII Remake, FFVIIR, and Pokémon. For FFVIIR, the challenge is the repetitive in-battle dialogue, which lacks variation and fails to adapt to the boss's changing states. For Pokémon, the main character, Red, does not say a word during gameplay. The study proposes a framework to generate in-game dialogue based on given knowledge. First, data is scraped from online sources, and then triples for knowledge graph instances are created. Finally, GPT-4 is prompted with the knowledge triples and a specific scenario to generate dialogue. Results. The study provides qualitative and quantitative evidence that demonstrates GPT-4's capability to act with defined personalities and generate dialogue. However, some flaws remain, such as GPT-4 being overly positive or more subtle personalities, such as maturity, tend to be of lower quality compared to more overt traits like timidity. This study aims to assist developers in crafting more nuanced filler dialogues, thereby enriching player immersion and enhancing the overall RPG experience. In the context of Final Fantasy VII Remake, Cloud Strife's greatest strength lies in his swordsmanship. Despite failing to meet the standards for candidates admitted into Soldier, his swordsmanship impressed one of the Turks. As a result of Mako experimentation by Hojo, Cloud has superhuman strength and is skilled in swordsmanship. His personality traits include being guilt-ridden, cold-hearted, and socially awkward, initially disliked by Barrett. In a battle scenario where Reno uses M-Shot and his HP is below half, Cloud would likely tell Barrett to pull back and use Cure. This response reflects Cloud's tactical thinking and concern for his allies' well-being. In another scenario involving the Scorpion Sentinel, Cloud would instruct Barrett to cover him while he handles the front, demonstrating his leadership and strategic mindset. In the context of Pokémon, the character Red is a mature trainer who interacts with NPCs like Sabrina, the gym leader. Sabrina has psychic powers, dislikes battling, and has Alakazam as her Pokémon. In a conversation with Red, Sabrina shares her vision of his arrival and her psychic abilities. Red responds by respecting her abilities and preferences, acknowledging her skills as a trainer and expressing honor at the chance to challenge her. Overall, the summaries highlight the key characteristics of Cloud, Strife and Red, showcasing their personalities, abilities, and interactions with other characters in their respective games. The scenarios demonstrate how these characters might respond in specific situations, reflecting their strategic thinking, concern for allies, and respect for opponents' abilities. This research explores the capabilities of GPT-4 in generating personality-based dialogue in video games. The study focuses on 2 games, Pokémon and Final Fantasy VII. In the Pokémon experiment, the researchers endowed the main character Red with 5 distinct personalities and generated 120 dialogues using GPT-4. Human evaluation revealed that GPT-4 can generate high-quality dialogue that aligns with predefined personality profiles. The results show that GPT-4 adapts its responses based on the personality trait assigned to Red and effectively incorporates specific information from the knowledge graph. The study also examined GPT-4's ability to generate dialogue for Cloud in Final Fantasy VII, specifically in boss battles. The researchers selected 5 scenarios for each boss and sampled 5 responses for each scenario, selecting the best one to illustrate. The results demonstrate that GPT-4 can generate dialogue that is context-dependent and leverages knowledge of the game's mechanics and characters. The human evaluation of Red's responses in the Pokémon experiment revealed that GPT-4 is good at personating a talkative Red, with the highest scores for both tasks. However, when Red is a mature trainer, the responses are rated the lowest for both tasks. This suggests that straightforward personalities are trivial for GPT-4 to derive, while those with unclear personalities might be challenging for GPT-4 to clearly express in words. The study highlights the potential of GPT-4 in generating personality-based dialogue in video games. The researchers propose future work, including expanding to other video game series and conducting more human evaluations. They also aim to explore how well GPT-4 can act as a game character and provide responses that are unexpected yet fitting. The results are presented in various figures and tables, including histograms illustrating the distribution of ratings for Red's responses and bar charts displaying the average ratings based on each personality type. The study demonstrates the capabilities of GPT-4 in generating high-quality dialogue that aligns with predefined personality profiles, and its potential applications in video game development. This study explores the capacity of GPT-4 to accurately emulate game characters and provide responses that align with their personalities and situational contexts. The researchers focus on main characters from 2 popular games, Final Fantasy VII and Pokémon, to investigate how well GPT-4 can maintain character consistency and utilize in-game knowledge when generating dialogue. The study presents a qualitative analysis of GPT-4's responses, which suggests that the model can maintain a high degree of character consistency. Additionally, the task of highlighting knowledge-based and situational responses provides further insights into the model's ability to integrate specific game details into its responses. The researchers draw on related works in dialogue and text generation in games, knowledge graph-enhanced text generation, and large language models, LLMs, in text-based games. They note that LLMs have been increasingly employed to enhance and innovate text-based games, with applications in quest generation, narrative generation, and dialogue generation. The study highlights the potential of GPT-4 in enhancing character-driven interactions in gaming, paving the way for more sophisticated and engaging LLMs-driven dialogue systems. Future steps involve refining the model through supervised fine-tuning to better align GPT-4's responses with the main character's personality traits. The researchers also aim to extend their evaluation methods to human evaluation and apply it to other characters and dialogue generation tasks within various game contexts. The study's findings are supported by related works, including the use of Word2Vec embeddings to introduce inference capabilities in text generation, Fulda et al. 2017, and the application of BERT to produce contextually relevant dialogue in action and fantasy game settings, Urbanic et al. 2019. The researchers also draw on knowledge graph-enhanced text generation, which has been instrumental in enhancing dialogue generation in fields such as medicine, question-answering systems, and gaming. Overall, the study demonstrates the potential of GPT-4 in enhancing character-driven interactions in gaming, highlighting the transformative potential of LLMs in redefining gaming experiences by providing rich, adaptive, and personalized content. The research paper discusses the development of a new benchmarking tool for dialogue generation, known as DikeChat, which utilizes dynamic knowledge graphs. This tool aims to evaluate the ability of dialogue generation models to incorporate and utilize external knowledge effectively. The authors, Yilin Tuan, Yun-Nung Chen, and Hunji Li, propose this benchmark as a means to advance the field of dialogue generation by providing a standardized method for assessing model performance. In addition to DikeChat, the paper also references other notable works in the field of dialogue generation. For instance, Jack Urbaniak et al.'s work on learning to speak and act in a fantasy text adventure game is mentioned. This study explores the use of reinforcement learning to train agents capable of understanding and responding appropriately within a dynamic game environment. Furthermore, the paper highlights the potential applications of dialogue generation in various domains, such as healthcare. Diksha Varshni et al.'s research on knowledge graph-assisted end-to-end medical dialogue generation is cited as an example of how dialogue models can be used to provide accurate and informative responses in medical settings. Lastly, the paper touches upon the role of deep learning language models in creating infinitely generated text adventures, as demonstrated by Nick Walton's work on AI Dungeon 2. This project showcases the capabilities of large-scale language models in generating coherent and engaging narratives. Overall, the paper presents a comprehensive overview of recent advancements in dialogue generation, emphasizing the importance of benchmarking tools like DikeChat for evaluating model performance and the diverse applications of dialogue models across different domains.